Okay, this video will be explain about steady state error. Okay, so before this, we discuss about first order, second order, and also the transient response and then steady state response. Okay, so everything in this chapter we want to analyze the performance of system. Okay, same for the steady state error. You want to know the error and then how to overcome the system to make sure there are no errors. Okay, so meaning that the error is zero. Okay, so first we want to know the meaning of steady state error. So steady state error is the difference between the input and the output for a prescribed test input as t approach infinity. So meaning that uh, steady state error is a gap between input and output. Okay, for the good performance or good system, there are no errors. So okay, so we want to overcome the system to make sure the error is zero. Okay, to analyze the steady state error, so we need to know the input. Okay, in our study, we just focus three input. Okay, step, ramp, and parabola. Okay, so for the step, this is the waveform. Okay, and then for the ramp is a straight line, and then the last one is a parabola, is a curve. Okay, and then for physical interpretation, we can also call as a gain. Okay, constant position Kp, constant velocity Kv, and then the last one constant acceleration Ka. Okay, so this one for the parabola, constant velocity for the ramp, and then constant position Kp for the step. Okay, and then this column show the function in time. Okay, so for the step is a 1, ramp is a t, and then parabola is a 1 over 2 t square. Okay, and then but for the Laplace transform, you can see the table of Laplace. Okay, for the step is a 1 over s, ramp 1 over s square, and the last one is a 1 over s3 for parabola. Okay, so let's define the equation of steady state error. Okay, so you can see here, okay, this error. Okay, this one is steady state error. So they are different. Okay, so you must remember they are different. Okay, so first I will explain to you this equation. Okay, so here you can see E is out, and then R and CS is enter to the summing point. So you can write down ES equal RS minus CS. Okay, and then for the CS is GS multiply ES. But we want the error, so we want E. Okay, so you need to replace C by ES. So you put here, and then you come out ES equal RS minus ESGS. And then bring ESGS to the left side, you can get E, okay, multiply by 1 plus GC. Okay, so and then you finally you get E equal I, okay, divided by 1 plus GS. Okay, this one for the error. But for the steady state error, okay, is steady state error is ESS equal limitation s opposed to 0, okay, s multiplied by E. Okay, so you just replace E by this equation. So and then lastly you can get ESS equal limitation s opposed to 0, s multiplied R divided by 1 plus GS. So these are two important for you to find the steady state error. Okay, this equation is important to you. Okay, so in this our case, kita just focus for unity feedback. Okay, negative unity feedback. Okay. Okay, so positive unity feedback, we have a different. Okay, so you need to remember. Okay. Okay, so next kita nak tahu dia punya KP, KV and KA for the each input. Okay, so first we go to the first input, step input. Okay, so you know that ESS equal limitation as opposed to 0 as S multiply R divided by 1 plus GS. Okay, so now you replace you replace R by 1 over S. Okay, so and then you cancel this one. Lastly you can get 1 over 1 plus limitation S opposed to 0 multiply GS. Okay. Okay, limitation S opposed to 0 GS. Okay, so here this one is a KT. Okay, constant position. Okay, in terms of step input, if you okay, so untuk dapatkan GS ni kita ada this one. Okay, so N ni. Okay, so you can see S power of N. Okay, N ni kita panggil dia type. Okay, untuk step input, kalau dia punya N equals 1 and more, so this system GS will be infinity. Okay, so this one will be infinity. You can put any number here and then finally you can get this one. Okay, limitation S opposed to 0, GS equal infinity. Okay, meaning that you put here this one to infinity, 1 divided by 1 plus infinity. So and then 1 divided by infinity you akan dapat 0. So meaning that type 1 and above, okay, so the steady state error for step input will be 0. But if there are no integration, okay, so and here equal to 0, so the steady state error is finite. Okay, so this one tertinggal T. Okay, so maksudnya kalau kat sini n equal 0, so maksudnya dia infinity dia ada value lah, so dia tak boleh jadi 0. So nak pastikan step input ni 0, so mesti n equal 1 and more. Okay. Okay, next for RAM input. So we just replace R by 1 over S square. Okay, so you cancel here, and then lastly you can get limitation S opposed 0. Okay, 1 divided by S plus SGS. So you put this one 0, so and lastly you can get 1 over limitation S opposed to 0 SGS. Okay, so this one limitation ni, okay, SGS is a KV, okay, constant velocity. Okay, so for the RAM input, if n equal to and more, so the limitation here will be infinity. So 1 divided by infinity equals 0. So untuk dapatkan steady state error equal 0, so the type must equal to or more. Okay. And if there are no integration, so meaning that the limitation S opposed to 0, SGS equals 0. So you put 1 divided by 0 is a 0. So 1 divided by 0 equal infinity. Okay, so meaning that kalau dia punya n less than 2, so dia ada error lah kat sini. ESS equal infinity. So something number. Okay, last one is a parabolic input. Okay, you replace R by 1 over S cube. Okay, so you cancel this one, so you akan tinggal lah this one, limitation S opposed 0, 1 over S square plus S2 GS. Put 0 here and then lastly you can get 1 over limitation S equal to 0, S square GS. Okay, so here this one is a KP, KA, okay, constant acceleration. Okay, beza dengan RAM and step input. So to get the 0 steady state error, you need to n equal to and more. So baru dia punya this limitation S square GS equal infinity. So you put 1 divided by infinity equal 0. But if n less than 3, so limitation S square GS will be 0, and then you put it here, 1 divided by 0 is infinity. So hopefully you understand, okay, macam mana nak dapat steady state error 0, okay. The important is a type number lah, okay. Okay, for the example, I will be explaining in the next video. Okay, so next, Okay, this one is a summarize. Okay, you can see apa yang saya cakap tadi. Okay, so this one for step input. Okay, UT. In this one, everything in term of time domain. Okay, TUT for the RAM, 1 over T square UT. This one for the parabolic. Okay, and then this one for position, constant KP. Okay, KV, and then the last one is KA. Okay. And then okay, so from here you can see the summarize for the system type. Okay, so as I explained before, okay, type 0. Okay, so when type 0, all the okay, so for the stat KP is a constant number, so the error is infinite. Okay, infinity. Okay, so something number. Bukan, it's not infinity, it's a something value. Okay, but for the RAM and parabola, so okay, KV equals 0, KA equals 0, so the error is infinity. Okay, so you just put here. Okay, and then for the type 1, okay, KP equal infinity, error is 0. So meaning that for step, okay, nak dapatkan dia punya steady state error 0, so mesti type 1 and above. Okay, so you can see, okay, 0. Okay, for the RAM to get the error steady, 0 steady state error is you need to type number 2. Okay, so baru you dapat steady state error 0. And then for the parabola, you need type 3. Okay, meaning that n must greater than 3. Equal 3 and greater than 3. Okay, and then you baru dapat value for the error. Okay, so I think that's all. Okay, summarize for the system. Okay, so you can see, okay, stability, this one natural response. Okay, what is a marginal stable? Okay, so you can read here. Okay, and then what is instability? Okay, and then this one stability. Okay, so you can read. Okay, and then this one for the pole in the left half plane. Okay, is stable. Pole in the right half plane unstable. Okay, if the pole are on J omega SZ and in the left half plane, so this one is marginally stable. Okay, as long as the pole on the J omega SZ are of unit multiplicity. Okay, it is unstable if there are any multiple J omega pole. Okay, and then the root ways, okay, you need okay, you without the calculate, you can find the number of pole in the right half plane. Okay, and then you can determine the system is stable or unstable. Okay, in summary, okay, for a step input to unit feedback system, the steady state error will be 0 if there is at least one pure integration in the forward path. Okay, if there are no integration, there will be a non-zero finite error. Okay, so the value of steady state error decrease and the static error constant increase. Okay, so that's all for the steady state error. Okay, I will explain root local in the next slide. Okay, that's all. Thank you.